So let's talk about locating irrational numbers on a number line. So if you watched a previous video locating rational numbers on the number line, this is going to be very similar to start. Our best bet is going to be to use our calculator and to grab the decimal version of these numbers because our brain is more familiar with working with decimals than with square roots and pi and other numbers that might be unusual to us in our daily lives. So you want to go ahead and grab your calculator and go ahead and enter these numbers. So our first one is the square root of 13 over 2, or the square root of 13 divided by 2. And just make sure your calculator is giving you a decimal version, and I suggest rounding it to the nearest hundredths place. So for us, that would be 1.8 there. Continue on down the line, so pause the video, do these on your own, and then we'll go ahead and place them on the number line. All right, so we have our decimal versions now. We're going to place them on the number line, and we're going to do this very similar to rational numbers, where we're going to make sure that we're sort of on the correct side of the halfway mark. We can't get perfectly exact with these. We don't have enough tick marks, but we want to be approximate. So A, 1.8, that's in between 1 and 2, but closer to 2. So I'm going to put it on the closer to 2 side of that halfway mark. B, negative 4.19. So we're in between negative 4 and negative 5, but we're definitely closer to negative 4 than we are to negative 5. So we're going to make sure that we're on the correct side of that halfway mark. So remember that negatives work in the opposite way of positive. So if that decimal point, if it's smaller than 5, you're closer to the right-hand side. If it's bigger, you're closer to the left. Whereas on the positives, it kind of works the opposite. Okay? So negative 8.94. So now we're in between negative 8 and negative 9 this time, but we're definitely closer to negative 9. So I'm going to put that on the left-hand side because remember, we're negatives here. So we're kind of working opposites. That 0.9 says we're closer to the left-hand side or further away from 0, right? The more negative you get, the further left you go and the further away from 0. Okay, so we're just going to continue on. 6.28 in between 6 and 7, but closer to 6. E, negative 0.87. So we're in between negative 1 and 0, but we're closer to negative 1. So we're going to stick that right there. And then 4.71. So in between 4 and 5, but this case we're closer to 5. So we're going to be on that right-hand side of that halfway mark. So it might be helpful when you're doing these to go ahead and draw your halfway mark on your number line so that you make sure that you're going on the correct side. But if you don't need to do that, don't worry about it. You don't have to. It's just a helpful hint. Okay, so just like with rational numbers, we're going to flip it around. And we're going to say, okay, I want to now take a point and represent it as an irrational number. That's quite bold. So we don't want to look at a fraction. We don't want to look at a terminating decimal. We want a non-terminating, non-repeating decimal, which is very hard for us to write. So instead, we're going to make use of square roots, and we're going to make use of pi in this case, okay? So first thing we're going to remember is the number pi is close to 3.14. That's typically how we approximate it. I'm going to use this little squiggly equal sign to mean approximate. So anything that's kind of around 3.14, we can just use pi, or we can use a multiple of pi. So 2 pi is approximately 6.28. So we can kind of use that a little bit. So let's look on here and see if anything can be approximated by pi. And if I'm looking at this guy, I see E, the letter E, right here, and I say, hey, that's a little bit past 3. Yeah, sure. If I want to represent that point as an irrational number and we're just doing approximations, I would say E is very close to pi. So let's approximate E as the irrational number pi, or approximately 3.14. Okay. The rest of these are not so easy. So for these, we're going to make use of a very similar strategy that we used in the last video for rational numbers, where we're going to rewrite our number line in something more useful to us. So for this, we're going to make use of what we call our perfect squares and how we can rewrite them, okay? So perfect squares are basically numbers that we obtain by taking another number and multiplying it by itself. So for example, 2 times 2 is 4, and we would call 4 our perfect square, okay? So I want to take a look at all of these numbers on the number line, and I want to write them as their perfect squares, okay? So we'll go ahead and start with 1. 1 times 1 is 1. We already did 2 times 2. Now we can have 3 times 3. And so on and so forth. So you continue this. All right, so we got a couple more on here. Our number line isn't very big, so we don't need many. Okay, so now what I want to look at is the relationship between these perfect squares and what we call a square root. Okay, so we talked briefly in our very first video talking about these number sets and dealing with real numbers, about the square root and the fact that it undoes a square. So multiplying a number by itself is essentially squaring it, right? So I said 36 is 6 times 6, right? So if I kind of take this idea and I say, all right, well, what's the square root of 36? This is essentially asking, what number did I multiply by itself to get 36? Well, that's 6. So if we look and do this for all of them, so 25, what's the square root of 25? What number did I multiply by itself to get to 25? Well, 5. And we can continue. So the square root of 16, we said, we used 4. Square root of 9, square root of 4, and square root of 1 is our unique guy, right, where it's just itself. Okay, well, we can use this to rewrite our number line. So if I look at this right-hand column that I created, I can see that, well, 1 is really just the square root of 1, right? 2 can be rewritten as the square root of 4. 3 can be rewritten as the square root of 9. 4 can be rewritten as the square root of 16. And we do need to get 5 here. So that's the square root of 25, right? And we can do the negatives. So this is going to be the negative square root of 1. So square roots, we can't take the square root of a negative number, but we can put that negative on the outside, which is what we're going to do. And we're going to continue on. So this would be the negative square root of 4, negative square root 9, negative square root 16, and negative square root 25. So we've done the hard part. We've relabeled our number line. Now we can start using these perfect squares and approximating numbers in between them. Okay, so let's start with A. Well, we know that A is negative. So let's put that down first. It's going to be negative something. So A is in between negative square root 25 and negative square root 16. So it's going to be in between. So A could be approximately the negative square root of a number in between 25 and 16, but a lot closer to 25 if we look at where A is located. So I might say 24. Okay. Let's look at B, and we're going to apply the same idea. So we know it's going to be negative, and we know it's going to be a square root, and we know it's going to be the square root of a number in between 9 and 4, but closer to 9. So I might say 7, negative square root 7. And go ahead and type that in your calculator, negative square root 7. See what that decimal is, right? And it's about negative 2.6, which makes sense because this is really negative 2 and negative 3 and negative 2.6 looks about where B would be. All right, let's keep going. C. So this is where it gets a little complicated because we don't really like expressing the square root of a decimal. It's not considered mathematically appropriate to write, say, maybe we would write the square root of 0.5. We don't really like doing that. So we're going to avoid that. And instead, we're going to kind of mess around with pi. And we're going to see if we can get an irrational number using pi to approximate that. So I know I want it to be smaller than 3.14, and I know I want it to be negative, so I'm going to be dividing. So let's check out what negative pi divided by 2 is going to be. Well, that's about negative 1.5, not small enough, so that doesn't work. Let's try to divide it by 3. So I'm making my denominator bigger so that when I divide, my number is going to be, well, the absolute value of my number is going to be smaller. So if I divide by 3, that's approximately negative 1.04. So still not quite right. So we still need to make that denominator a little bit bigger. So let's try 4. All right, so real quick, type that in your calculator. And that will give us negative 0.7. But I would think that negative 0.7 would be a little bit closer to that negative 1 than where our c is located. So I'm going to step it up. I'm going to do one more. I'm going to try negative pi over 5. And we're going to see if that gets us a little bit closer to our goal. So that's negative 0.6. Still not quite there, but I could go for it or go larger. I'm going to try a big jump though, and we're going to try negative pi over 8 and see what that gives us, because we're not quite getting there fast enough for my tastes. All right, that's negative 3.9. So if I round it about negative 0.4, I like that one. That's about negative 0.39, which is about where C is. So you got to play around with them a little bit. All right, last two real quick. D, I would approximate as the square root of 2, and E might be approximated as the square root of 11. So the big thing here, big part, is rewriting that number line, and then that gives us the tools we need to approximate most of these numbers.